We'll start our today's discussion, and from today we'll be starting the second module. The module 1 is over, which is about the background of operating system, functions of operating system, types of operating system, the services that are being provided by the operating system, system calls. These things we have read in module 1, the fundamental things. From module 2 onwards, we'll be actually reading what is being done in the process, that is the process management, then we'll go for memory management, and then we'll go for file, disks, and other management in different modules. Module 2 is dedicated for the process management. As we know that out of all the components of the operating system, process management is the most important thing that the operating system does. Correct? So, therefore, we'll have a lot of things we have to read over here in the process management itself. There is a query from Pratik that today if we revise module 1 and start module 2 from next class. See, I don't think that entire one class is required for revising the module 1, because it doesn't have a lot of things, lot of problems, and those things are not being covered. Actually, the problem and complexity will come from module 2 onwards. But still, I'll encourage that if you have any doubt from module 1, we can ask over here, we can discuss, then we can move to module 2. There is nothing fast over here. If you need the module 1 to be revised, ask some questions so that I will explain those again. While starting the module 2, the module 1, whatever the documents I have, the slides I have, I'll try to give it in the group itself. I'll put it in the WhatsApp group. So if you have any doubt on module 1, we can have a discussion. We can have discuss over here. We can ask your doubts over here. Anybody is having any doubt on the module 1? This is about the operating system, its types, the functions, the components, the system services, types of operating systems. These things we have discussed over there. We have discussed these things over here, module 1. Okay, I think it is not, students are not being prepared to ask the questions. What you can do over here, if you have any query, you keep it with you by writing those queries on your notebook, so that in the next class, even if you start the module 2, then also we can raise the question at the beginning of the class. Maybe in the next class at the beginning, you can ask those questions. And during my class, anytime if you have any doubt, you can ask me from the previous classes. There's no problem. So let us start with the module 2 then. In the module 2, the first one was, as I said, we'll go for the process management. Most important work in the computer is the processor, and most important component, and the most important thing in our operating system is also the process management. Just a second. Hello, sorry for disturbance. So in module 1, we have covered these things: overview, evaluation, types. We have discussed about the batch programming, multi-programming, time sharing, personal computers, parallel, distributed, and real-time systems. We have discussed about the operating system, system components, and system calls. Module 2 is the one of the most important topic will be covered over here. The different concepts of the process management and different scheduling algorithms, and the problems on these problems will be solved from the CPU scheduling algorithm. And this is particularly, it will be helpful for those who are been preparing for the GATE exam. You will find that many of the questions are being from these two units, module 2 and module 3. Okay, so let us move to the first the process and the concept of the process. So we'll go for the concept of the process. As I have already told you, what is which one we say as a process? The program is in the state of execution. So program also, we can say program a process, but when the program is executing, we say it is in the state of, it is a process actually. In the state of execution of a program is known as the process. So if you try to find out the difference between a program and a process, because till now I was talking about the program, now we'll go for talking about the processes. Is these two are different? It says that there are some difference between program and a process. What is a program is? The program is usually the program that you write or you are executing that will be residing on the disk. It will be residing on the disk. When you try to execute, you bring it to the memory. For that program, a process is created and that is given for execution. Correct? So these are the differences. Some of the differences we have find out. We can see over here the program contains a set of instructions designed to complete a specific task. So program is nothing but a set of instructions that have been designed for doing a specific task. What is a process? Process is an instance of executing a program. Here in the program, what I say, there are some instructions. Process is that when these instructions are executing, when it is being executing, instruction 1 is executed, then 2 is executed, 3, then in the state of execution, then we say it is a process. So when this program is there, is designed, it is actually a passive entity because it is there in the disk itself. So program is a passive entity as it resides in the secondary memory. Program is a passive entity, correct? Whereas if you talk about the process, process is an active entity because that executes. Here it is only resides. Where it is resides? It resides in the secondary memory, whereas the process resides in the main memory because program is loaded to the main memory, then it is getting executed. So process is an active entity. Program exists at a single place and continues to exist until it is deleted. If you have saved it on your disk, it is there on the disk itself in the same place. It is not that it is changing the place in your disk. Suppose your program is there on your hard drive, on your pen drive, or on CD-ROM. It is being placed at a particular location. It is not going to change unless you explicitly do it. But in process, what it does, while it is running, during its execution, it may change its place. It may be sometimes it may be loaded at the beginning of the memory, maybe shifted to some other location. So process exists for a limited span of time as it gets terminated after a completion of the task. Whereas the program is not being terminated, it is there in the memory itself. Process says that after its completion, it has to terminate. So process has a lifetime, it's a lifespan. But program is, it will be there in the memory unless it is not being deleted. So therefore, the program is a static entity, whereas the process we say as a dynamic entity, because process is a passive, therefore it is a static entity. Process is a active, therefore it is a dynamic entity. Program doesn't have any resource requirement. It only requires a memory space for storing the information. Suppose I want to store a C program. What I require only hard disk space, nothing more. But if I want to execute a program, many things are required. I require memory. The program might be requiring keyboard to input. It might be requiring something to display, which is monitor is required. That might be requiring some memory. So different resources are being required for the process. So process has a high resource requirement. It needs resources like CPU, memory address, input output during its lifetime. So program doesn't have any control block. The program doesn't have any control block. Process has its own control block. The process has its own control block called process. So now you might be thinking, what is this control block? For the time being, you omit it. I will tell you that what is control block. For every program, a process, the information are being kept. For every process, some informations are being kept. Those are being put in a block that is called the process control block. All information about a process. Those things are not required for a program. Those are only required for a process. So the process control block is required for a process, whereas that may not be required for a program. Is it understood? Anybody having doubt for program and versus process? Okay. Now going to the concept of the process. An operating system executes a variety of programs. What are the programs? In batch system, the program may be executed in a batch system, or program may be executed in a time shared system or a multi-programming system. In batch system, these are called jobs. In time shared system, these are user programs or tasks. In your textbook, the job and process are used almost interchangeably. That means if you are writing job, it means that is a process. When the process is written, it means that it is a job. So the textbook, the Galvin book, uses these two terms, job and process, almost interchangeably it is being used. The meaning is same, whether you are using a job or a process. The more process is more technical, more accurate. So process is what? A program in execution. Process is in short, we can say a program is in execution. So process execution must progress in sequential fashion. Process execution must progress in sequential fashion. That means I want to execute a program. Program will be loaded to the memory. That program will now become a process. That process may have a number of instructions to execute. These instructions will be executed in a sequence. These will be executed in a sequence. So a process in memory includes the following. A process in memory includes the following. What it follows is a text section is the program code. Suppose I want to execute a program. The program has to be stored in the memory or not. That program code, the code, what you have written, the C language, whatever the code or the object code, the object code is being stored in this area, in the text area. Is it understood? The text section contains the program code itself, which program you are writing. The object code is stored in this text. Correct? So once the program is stored over here, there must be a counter which will go on, which will point to the first instruction. Which will point to the first instruction. Why it is there? Because that instruction is going to be executed. When the first instruction is sent for execution, the pointer should go to the next one. So that next instruction will be executed. So that pointer is known as the program counter. It is a register actually. It is a register which stores the address of the next instruction to be executed. Is it understood? So my program is stored in this over here in this text area. Program counter is pointing to the first instruction. Program counter is pointing to the first instruction. So it will go on executing each instruction sequentially. Right? So what it holds? It holds the address of the next instruction to be executed. So program counter works over here in this text area. Then we can see over, so text area in which your program is stored. There is an area called stack area. This is also a temporary area. What is being used for? This is used for function parameters, return addresses, local variables, arrays. These are being stored over here. The function parameters, return addresses, local values, arrays, those are being stored in the stack. Those are stored in the stack. Is it understood? So that means you know that if it is a stack means it will be a what? It will be pushed one after another, so that whenever the parameters to be extracted, it will be extracted from the stack. If the return address to be extracted, it will be return address will be extracted from the stack, or the local variables can be extracted from the stack. Is it understood? So my text is over here. All these function parameter, return addresses, local variables over here, and this data section contains all the global variables. Why the global variables have separate space? Because global variables are accessed by all other memory locations, are all accessible through other programs, other functions. Therefore, they have to be kept in separate memory area, which can have access to other memories, other programs. Is it understood? So data area contains what? The global variables. Stack area contains only local variables with some return addresses, function parameters and all. There is another kind of area, is called the heap area. This is try to understand what is this heap area is. The stack and data area, what you are saying, this is being confined, that you are declaring integer, you know that 2 bytes. If it is a stack, you are allocating some memory, that is being fixed. But sometimes we allocate memory dynamically. We go for malloc functions, calloc functions, new operators. Those are being used for allocating memory dynamically. For dynamic memory allocation, the memory is allocated from the heap. To remember, from that dynamic memory allocation, the memory is allocated through heap. From the heap, it will go on allocating the memory. Up to how much? Till the space is there, it will go on allocating the memory. Correct? So heap contains the memory dynamically allocated during runtime. During the execution time, if some memory is allocated, it is being allocated from this heap area. Correct? So now what you have heap area which can grow in this way, because dynamically you are allocating the memory. You can allocate memory up to the what is free. So heap area is growing in this direction. Similarly, if you go on declaring the variables, return addresses, function parameters, this will also grow in this area. So none of them will cross each other. So there will be a boundary, although it is being nothing is stored over here, but there will be a virtual boundary over here. It doesn't mean that this can access the stack area or stack can have access to this heap area. So this free space, both stack and heap are growing in opposite direction. So it depends then how much memory you are allocating dynamically, or how the parameter, return address or local variables, how much number of local variables you are using, right? Okay, very good question. The question is that, is there any ratio in which areas of stack, text, heap and data is allocated to the memory? It is truly speaking, there is no specific area. It is actually depends on the operating system and the system configuration. For example, if I say you have 4 GB of RAM, the allocation for this is different, and for 2 GB RAM it will be different. So so what you have, so you do not have actually a fixed ratio that the stack, heap or memory is allocated for this area. It depends on the amount of memory that is available. The memory allocation for 4 GB or for 2 GB, it is not proportionate exactly. It depends on the operating system that you are using and the hardware architecture, both. So there is no fixed ratio for the same. So now, so we have this different area. Here it says the program is a passive entity, where whereas process is an active entity. We have already, I have already told you that program resides in the secondary memory, so it is a passive entity. Once it is being loaded into the memory in this text area, then it becomes active entity, right? And that is our process. So processes, this is the memory allocation that I said here. The multiple programs can also reside. Multiple programs will have different text area, different data area, like that. Is it understood? This is how the process actually being stored in the memory. Now this is one of the important diagram you will find in most operating system. This diagram is called the process state diagram. Process state diagram. This diagram. This is also known as a snail diagram. I don't know whether it looks like a snail or not, but it is also called as a snail diagram, right? The snail diagram for what? For process, defining the different process states. What it says, during the program execution, starting from the admission of the process is admitted till it is getting terminated. It has to go through different states. Like in your college, a student get the day on which the student get admitted in the first year. Now the admissions are going on. The first year when the student admitted until the fourth year he get passed and go out of the college. It goes through different states. In somewhere it may be reading in the class, sometimes it's in lab, sometimes in the hostel, in the library. So different states going through different. So process as well is going through, starting from this inception, from its creation till its termination, that will go through different states. These states are actually important. We must know that in which states the process will move. Basically, in general, the process will go through 5 different states. The process will go through 5 different states. Although in some of the text or some of the textbooks or some other books, few more states are being added. I will explain the next slide. But the basic diagram is this snail diagram. So we will have 5 different processes. Sorry, 5 different states. Sorry, 5 different states through which a process can go through during its lifetime. Correct? What are those? Those are new, ready, running, waiting, and terminated. New, ready, running, waiting, and terminated. So as a process executes, it changes its state. As a process executes, it changes its state. The state need to be changed. At any moment, a process should be in any one of the following state. So it says that if a particular snapshot you will take, you will say that where this particular process is, you will get a particular state on which it is running. Either any one of these. If you want to check that how many processes are running, you just in a command like in your Linux, you can type ps-el. You will see that what are the processes are running. ps-el. And Windows, I have already showed you that how if you press the Alt Control Delete, you will go to the tab, process tab. You will see that how many processes are running. We have already told that user processes are running and background processes, system processes are running, right? So each of these processes, whether it is a system process or user process, that has to go through through these states only. So at a particular moment, it may be in any of these states. Not necessary that every process will go through all the 5 states, but at a particular moment, it must be in any one of the states. What are these states are? When the program is brought into the main memory, that means it is when the main memory itself, it is in the new state. It's brought into the memory. So process is created. So from the program, a process is created. When a process is created in the main memory, then in that time it is in new state. This is a new process is created. Is that understood? It was earlier, it was a program, it has brought into the memory. So now that becomes a process. So we say a process is created. So if process is created, it is being created in main memory or secondary memory? It is being created in the main memory, because while it was there in the disk, it was a program. While it was there on the disk, it was a program. So now it is in the memory, so we say it is a process. Okay. So now after that, when the process is being created, the process is admitted. The process is admitted for the execution. It is called the ready state. When it will go to ready state? Ready state means for that process, some resources are being allocated. Now it is ready to execute. Try to understand. Process is created. It might be requiring many resources. If some resources are available and it is ready to execute, then it will be admitted to the ready queue. That means in the ready state, the process is ready for execution. Execution means the processor is waiting to be assigned to a process. That means it is ready. The process is ready to be assigned to the processor. Who will execute? The CPU will execute. In the if a process, suppose process is P1. P1 is in the ready state, means that the P1 is in the ready state means that P1 is ready to execute by the CPU. P1 is ready to execute by the CPU. Correct? So process is waiting to be assigned to the processor. Is that clear? So from the new state, the process is admitted to the ready state. When it will get admitted? When the resources are available, a part of the resources are available, it will go to the ready state. Ready means it is now ready to execute. So the process is waiting to be assigned by the processor. So it is being ready over here. Correct? Now from the ready state, the process is dispatched to the running state. From the ready state, the process is dispatched to the running state. Running state means here the CPU is there. Here the CPU is there. So CPU will execute that process. Is it understood what I am saying? The process, when the process is ready to execute, resources are allocated, it will go to the ready state. From the ready state, whenever a process chance will come, it will be given to the processor for execution. That means the process is dispatched for running. So running state means the instructions are being executed. The CPU resides over here. CPU is executing. The CPU is executing a process. Correct? Now question is that in a multi-programming operating system, it is not that only one process is being executed. We have seen over there in the previous classes that there are many system processes and many user processes might be running at the same time. They are there in the memory at the same time. Are you getting me? We have many processes are being created. When it comes to the memory, it's a new state, new one is created, and if it is resources are allocated, it will go to ready state. So in the ready state, it is not that only one process will be present. Along with your one process, there might be several other processes might be waiting over there. There might be several processes are there. Those processes, all those processes which are ready to execute, all those processes which are ready to execute are put in this ready queue. The queue is maintained over here is called the ready queue, and those processes are being kept in the ready queue. Is that understood? So ready state means what? Resources are allocated and it is ready for execution. Now there are several number of processes. Suppose I have 5 processes, Word, Excel, PowerPoint, like that 5 processes are there. Processor All these 5 are in the ready state, means all are ready to be executed, but all cannot be sent at the same time to the CPU. CPU can execute only one process at a time. So So the processes, there might be multiple processes in the ready queue, correct? But all these processes cannot execute at the same time. So one of the process out of these processes which are in the ready queue has to be selected, and the control must be given to the CPU. So which process will be selected? That will be selected by some algorithm. It's called the scheduling algorithm, CPU scheduling algorithm. Is it clear? There are multiple processes maybe there in the ready queue, in their ready state. So a ready queue is maintained. A particular process is selected from that, and the control is given to the processor for execution. So some scheduling algorithms are used over here. These are called the CPU scheduling algorithms. Once the process is selected, then a module called dispatcher, the module dispatcher is there, which will connect that process to the CPU. CPU is over here in the running state. Correct? You understood this new ready and running? Okay. Now, suppose the process is in a running state, it's executing now. The process is executing. During the process execution, it may happen, a IO or event may occur. For example, in the while executing, there is a statement, the scanf %d ampersand of a. Scanf means from where you are inputting, from the keyboard you are inputting. This is a IO or event. Are you getting me? So during the execution, there might be some IO may occur or event may occur. So in that, if that IO occur, if you are reading from a disk should be ready, or you are writing to the monitor, that has to be ready. So if you have any input output operation, so then the process will be taken out from the running state to the waiting state. Correct? So program is admitted. A program is in a new state. It is being admitted when the resources are available to the ready state. From the ready state, multiple processes may be there, from which one of the process is selected by the scheduling algorithm by the scheduler, and it will be given to the CPU for running by the dispatcher. So now the process is in the running state. While it is running, two things may happen. Either a IO may occur or a interrupt may occur. Either a IO may occur like this, or a interrupt may occur. If a IO or event will occur, then the process will enter into waiting state. If an IO occur, printf, scanf, reading from the disk or writing to the disk, there only the IO occurs. If a IO occurs, it goes to the waiting state. A process is waiting for some event to occur. The process is waiting for some event. Event means what? IO event or is it one other event? Event to occur. Correct? Suppose I have a scanf statement. So scanf statement will bring the program over here in the waiting state. Correct? So after the waiting state is over, my IO is completed or event is completed. I have a IO or event occur for which from the running state I come to the waiting state. So when that completed, when the IO or event is completed, it is the process is again brought back to the ready state. That means there were already some processes there. So this will be added at the end of the queue. This will be added at the end of the queue. Is it understood? So waiting state is the process is waiting for some event to occur. So now when the process is, look over here. So new to admitted, it comes to ready, ready to scheduler, it will select and dispatch to the running state. From running state, it may go to the, if any IO occur, then it may go to the waiting state. From the waiting state, when the IO is completed, it will go back to the ready state. But there might be a chance from the running state, it may go back to the ready state again. The process is selected, given for execution. During its execution, a interrupt may occur. A interrupt may occur. If the interrupt occurs, the process is brought back to the ready state again. For example, if I say in a time sharing operating system, when the time expires for a particular process, the control returns back, the process again returns back to the ready state. Correct? There are, because for every process, a fixed time slot is given in a time sharing system. In a time sharing operating system, every process is given with a fixed time. So when it is over, it automatically goes to the next one. So in that case, the process is brought back to the ready state again. In that case, it is brought back to the ready state again. Correct? So now suppose after execution, all the instructions are executed, then the process has to exit or it has to be terminated. The process has to exit or has to terminate. So from the running state, it goes to terminate state. The process has finished its execution. Correct? So this is about the process state diagram. If usually it comes as a question, what you will do, you will have to draw the Snell diagram and the functions of each of these states. Do you have any doubt on this process state? This is diagram is important, therefore I am asking. If you have any doubt on the process state, you may raise your hand or you can ask, unmute yourself and ask the question. Okay. Now, in the previous diagram, what we have, how many states are over here? We were discussing about the 5 steps, and also I told these are the 5 basic states. If you go for many of the books, you will find these 5 basic stages of basic states of what FI process. But in some books, in some textbooks or reference books, you'll find there are also another 2 states are being assigned, is called blocked suspended or ready suspended. Correct? In the previous diagram is the exactly the same way. It is the Snell diagram that you can see. Instead of waiting, we have written over blocked. This is blocked suspend and this is ready suspend. I will explain you. These things already I have explained you from new, ready, running, blocked and terminated. This part already I have told you. Instead of the blocked, there I told that it is waiting. It is waiting. Now I am saying is a block, and there is a block suspend and ready suspend. Assume. So at any moment, the process should be any one of the following state again. So what we have discussed earlier. What is new state? The same as it was there, contains the processes which are newly coming for execution. Which are newly coming for execution are put in the new state. Take the time. I'll explain this. Let me take the attendance because otherwise it may somebody may end the meeting. So let me tell the attendance and then we'll go for we'll resume the discussion. Number 1, 2 is absent. 3 absent. 4, 5, 6. Okay, let me tell the students those are absent. Roll number 2, roll number 3, 7, 16, 22, 25, 27, 30, 37, 39, 73. Okay. So let us few 2-3 minutes I will take. These states I am not explaining. This new ready running terminated already you know. This block state says that contain the processes which are in the memory and waiting for an event occurrence. That means if an IO occur, it goes to the block. This is over there in IO occur, it goes to the waiting state. Here we say it's a block state. The same waiting state here we say it's a block state because program is being blocked. After the IO, this is waiting for IO. When the IO completes, it goes to the ready. Now from the block state, it may go to the block suspend, block suspended. So what is block suspended? Block suspended contains processes which are in the secondary memory and waiting an event to occur. So sometimes to not available of the memory, the process may be brought to the secondary storage. So then it will be in the block suspended. So sometimes after block suspended, it may arise again, it go to the block from the block to ready, and again from ready to it will dispatch to the running state. And it may happen from block state, it may go to the ready state. Sorry, ready suspended state. What is ready suspended state? The processes in ready suspended state are in secondary memory. This is there. So it is also in secondary memory as it is there in the block suspended. They were initially in the ready state in the main memory. Initially it was there, but lack of memory forced them to suspend it. So because the memory was not available, so we suspended, suspended and get placed in the secondary memory. So sometimes this ready from the ready state, it is being suspended and it may be brought to the ready suspended over here. From the ready state, it doesn't get that amount of memory, it is being suspended. But lack of memory forced them to suspend it and gets placed in the secondary. And whenever memory is available, it will be resumed. Is it understood? So this is the same Snell diagram, but slightly being extended over here. It is being extended. Is there any doubt? Is there any doubt over here for the process state diagram?